Hello everyone, this is the second video for Activity 3.5 Chesapeake Bay Oysters Part 2. We will be covering pages 90 and 91. Your partner examine the following three graphs. For each graph, identify and discuss any patterns or trends you see in the graphs. So let's start with first two graphs. But before that, as we should know, the first thing that we need to do is looking at the titles and the labels of the graph. So the first one, annual nitrogen runoff in Chesapeake Bay, x-axis year, y-axis nitrogen runoff. Second graph, total size of dead zones in Chesapeake Bay, x-axis year, y-axis dead zone size. Third graph, annual oyster harvest in Chesapeake Bay, x-axis year again, y-axis oyster harvest. So the first graph is about nitrogen runoff, second graph is about dead zones, the size of dead zones, and the third one is oyster harvest. So before we start, we should expect to see these correlations. Number one, as the size of or nitrogen, if nitrogen runoff increases, we should expect the size of dead zone, it should increase too. And the second one, if the size of dead zones increase, the oyster harvest should decrease. Okay, let's see if we can find these patterns. Look at first two graphs, nitrogen runoff and total size of dead zones, and you can clearly see that as one increases, the other increases, as one decreases, the other decreases too, and overall, these two graphs looks pretty similar, and this is something that we expect because we know that primary cause for dead zones is total nitrogen runoff. And the third one, as we said over here, we expect to see that if the size of dead zone increases, oyster harvest should decrease. So 1993, the size of dead zone increases a lot from this point to this point, and you can see clearly on the annual harvest that from 1990 to 1993 oyster harvest decreases a lot. And also during this time period, the size of dead zones again increases a lot here, and oyster harvest decreases. It decreases a lot too. So this is an outcome that we were expecting, and these findings are going to help you to complete your argument tool. Now, argument tool is going to be the final video that I'm going to create for activity 3.5. Analysis. Suppose a species of fish that live in the Chesapeake Bay only reproduce during July. For the fish eggs to mature properly and hatch, there must be at least 2 milligrams per liter of oxygen in the water. Based on the diagram on the right, answer the following. A. Which resources will the fish have to compete in order to breed successfully? As it says in the introduction, these species require certain levels of oxygen in the water. So the first thing that they are going to compete is water with enough oxygen levels. Even though these species choose different areas to lay their eggs, species 2 chooses lower areas in the bay, and species 1 chooses higher areas in the bay. However, since dead zones are their sizes changing, if the situation gets worse, the levels of oxygen may drop more. So the yellow area that technically on this diagram has enough oxygen for species 2, let's choose another color, for species 2 might not have enough oxygen later if the situation gets worse. So if that happens, what's going to happen is the species 2 might need to move upward in the bay, and if they do, now they also will start competing for space. So these two abiotic factors are going to impact the fish population, and the competition for these two factors are going to take place in the same species, also between species 1 and 2. Second question is, what effect might this competition have on the populations of the fish, of the two fish, both long and short term? In the short term, we can expect that both species their population is going to decrease because there is now competition, and it is going to cause um, some eggs not to mature properly, or not even be laid if the fish cannot find enough space. And this is the short term. We expect both populations will be impacted negatively. The long-term effect, however, long-term effects are, since the species too needs deeper spaces for to lay eggs, and in the dead zones, as you go down, the levels of oxygen decreases. So this is going to cause species 2 to have more trouble because they are not going to lay eggs towards the surface. So as you go down in the dead zones, the levels of oxygen decreases. We can also see that pattern in this illustration. So in the long term, we can say that species 2 is going to be impacted more, since they need more depth to lay their eggs. But unfortunately, as you go down the dead zones, the levels of oxygen decreases. Maybe if situation gets really bad and the dead zone keeps increasing, we might see that the yellow parts may turn into red too, because the levels of oxygen might constantly decrease in a dead zone.